Okay, so I want to do an example from, this is 1.2, number 2D, right? Which says, I want to check that this is a solution, and there's some kind of typo going on in the book, right? So there's at least a y equals the quantity 1 plus c e to the minus x squared over 2. And then there's some confusing nonsense here, which I'm going to ignore at least for first, right?
I was able to see it for some reason, I don't know why.
Good. Stop ruining the fun. Let me dork with it for a minute. And the other stuff, and then this is supposed to be a solution for 2y prime plus x times the quantity y squared minus 1 equals 0. And I suspect that maybe they meant to multiply by the other stuff that was here. Right? But let me just try this and see. All they want me to know, all they want me to do is verify that this is a solution of the differential equation on some interval for some choice of constants. Right? Or for any choice of constants, really. So how would you go about trying this to begin with?
Find y prime.
Yeah. Right? Like, you need to take this and plug it in there, right? So fundamentally, you just stick this in any place you see a y. So you wonder, maybe there's 2 times this c e to the minus x squared over 2 prime, right? Plus x times that whole business all squared minus 1. And I'm wondering, is this 0? You guys all with me on that? Okay, so what do you get when you differentiate this whole nonsense?
Negative x c e to the negative x squared over 2.
Okay, let's see. So 1 differentiates to 0, right? And then you get a c times e to the minus x squared over 2. I'm really looking for y prime over here in the margin, right? And then, where'd you get the rest of that chunk, you said?
Chain rule.
From the derivative of the inside the chain rule, right? So there should be a times minus 2x over 2, right? Okay, so I think my y prime is c, or minus cx e to the minus x squared over 2, right? You guys with me on that? Okay, so that should go in for that stuff, right, for the y prime. So I'm looking at minus 2cx e to the minus x squared over 2 plus x times all this junk. Is with me on that? Okay, and so in here, if you FOIL this out a little bit, you get 1 plus 2c e to the minus x squared over 2 plus what?
C squared.
C e to the minus x squared over 2 all squared, maybe? Is that what you said? I think I'm with that, right? That's if you square the quantity a plus b, right? You get a squared, 2ab, and b squared. And then there's a minus 1 that was just in there, and I'm still wondering, is this 0?
Could be.
Everybody on board? And what did you say?
Said it could be.
Could be! Yeah, that's basically the stage I'm at. So what do I do?
Distribute x to the inside.
Yeah, like start looking for stuff to cancel. 1 minus 1 is 0. Good deal. Okay, so if I multiply this out a little bit, I got my first guy up front, my minus 2 cx e to the minus x squared over 2. And then I got a plus, oh, cool. There's a 2xc e to the minus x squared over 2, right? Nice, that's going to cancel. And then what else I got?
The squared business.
Crap. Something else, right? So I got a plus c e to the minus x squared.
C,
C squared. Thank you.
And then times x.
And times x. Good call. Thank you for correcting my going too fast arithmetic. And what's this supposed to equal?
0.
0. But what?
It doesn't, unless x is 0. It doesn't unless x.
Yeah, so these two cancel, right? So, and what you're left with is xc squared e to the minus x squared is 0, maybe? And because you guys are good algebra students, right? What are you telling me about this thing?
X has to be 0.
Yeah, this would imply that x is 0, right? Or c is 0, maybe? Right? Because you're doing what to this whole thing?
0 identity.
Yeah, you're
Zero
applying
product
the
rule.
zero product rule to both, to kind of all the objects, right? This is an e to a power, that's not going to be 0. But one of these two should be 0, right? Except, what have I done that's kind of actually bizarre?
We should have unrestricted x's, right?
Yeah.
Yeah, or at least largely
Yeah.
unrestricted x's. You guys see that? Like, I'm trying to solve a differential equation. Like, I'm trying to come up with a function that when I plug it in here, it works. And what did I come up with?
Solution.
I came up with a function that works for one particular x. That's not really very helpful, right? Like if you want to know about the cooling of your building or something and you get a solution that works for one particular time, that's not really any better than a thermometer, right? Okay, so something went wrong. This thing is not a solution, right? So what went wrong is, Tony, you worked through this. That was supposed to be multiplication at the beginning?
yeah.
Yeah. Okay, so there's a typo here. And we were supposed to have this thing multiplied by 1 minus c e to the minus x squared over 2.
To the minus 1.
To the
So the negative 1.
Ah.
Okay, and now if we went through and differentiated this and plugged it into all the right spots, we would get something that's true at the end. You guys all with that? So what we need to do is take the LaTeX files for the textbook and fix it. Which we can do because we have an open source textbook. So this video will be totally meaningless next time because that error won't exist.
I wonder why I saw mine.
What's up?
I wonder why mine had it, and I took it off the website. That's weird.
Oh, yours was multiplication?
Yeah, but mine was just like that. I could read it. Now, I don't know why.
Did you?
Like in mine it's there, but there's a semicolon.
Yeah, mine
Yeah.
was a semicolon, and I was like
Mine
really
didn't have
confused
it.
on that.
It's weird.
Interesting.
Yeah.
So there are two versions of this book available, and it's also possible that that's just brain.
Yeah,
Yeah.
yeah.
It could just be that your brain filled in that top dot on the semicolon and forgot the comma because it was meaningless in the context.
I think you're right.
That would be cool,
Yeah.
right? Sometimes the human brain is amazing. It does really cool stuff.
It's funny.
And sometimes it's less amazing. It does less cool stuff. Cool? Questions on this? Do you guys believe that if the problem had that multiplication in it, you could differentiate? What would you need?
15 minutes.
15 minutes and the chain rule and
The
either the quotient rule or the product rule. I don't care which.
It's not.
Cool?